Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
The use of direct injection in gasoline engines is the dominant technology of modern automobile construction. TSI is an abbreviation of the patented Volkswagen concern designation of engines with turbocharging and direct injection. Turbo-stratified injection is used in most modern cars produced by VAG Group, Audi, Skoda, Volkswagen, and Seat. TSI technology is the next stage of development of FSI motors, which have direct injection, but are not equipped with turbocharging. Consider not only the principle of operation, but also a number of design disadvantages that are a serious headache for owners of TSI motors. Advantages. TSI motors have a number of undeniable advantages. Formation of mixture formation. Based on sensor readings, the ECU can form four types of mixture: pore layer-by-layer mixture with the addition of exhaust gases, pore. Homogeneous mixture without the addition of exhaust gases, homogeneous stoichiometric mixture with the addition of exhaust gases. Homogeneous stoichiometric mixture without the addition of exhaust gases. The choice will depend on the amount of incoming air, the degree of throttle opening, engine speed, engine temperature, and other factors. Such selective mixing allows to get the maximum output from the injected fuel, turbocharging, which allows to increase filling of the cylinders with fresh air. TSI engines can be equipped with single-stage or combined air injection system. In the first case, the engine has a standard turbine, the advantages and algorithm of operation of which is known to many motorists. The combined system has not only a turbine, but also a mechanical supercharger of the Roots type. The principle of operation of such a system is of special interest, so further we will consider it in detail. Tuning potential. The majority of TSI motors lend themselves well to chip tuning. Owners wishing to add a few dozens of horses should think about the life of the engine and gearbox, which can be drastically reduced by improper chipping. Principle of operation of the injection system. The main feature of the direct injection system in the TSI engine is control of atomization method and delivery time. This advantage is achieved by competent ECU programming. Otherwise, the feeding system, in fact, does not differ from that used on the engines of many other manufacturers. Dual turbocharging system. In many respects, it is the combination of a turbine and a mechanical supercharger that allowed TSI motors to win more than one Engine of the Year title. Let's take a look at how this solution is implemented. The main principle of operation is airflow distribution. By changing the flow rate, as well as the amount of incoming air, it is possible to regulate the quality of mixture formation in the cylinders. Depending on the crankshaft RPM and throttle position, the following turbocharger control algorithms can be distinguished, up to 1000 RPM. The engine operates in a non-turbocharged mode. All air is sucked in by the cylinders. Between 1000 and 2400 RPM, the mechanical supercharger comes into operation. With the help of an electromagnetic clutch, two rotors are engaged. One of them sucks in air and the second one pressurizes the intake tract. If the driver in the range of 2400 to 3500 RPM sharply presses the accelerator pedal, there is a joint work of the supercharger type Roots and a conventional turbine. At speeds above 3500 kRPM, the turbine alone is responsible for air injection. Controls. One of the main elements of this system is the damper, which redistributes the airflow between the turbine and the supercharger. The adjustment is done by means of a servo. For example, at 1000 to 2400 RPM, the air is supplied only through the supercharger, and after 3500 only to the turbocharger. The ECU constantly polls a number of sensors to control this entire system: IDA sensor, which measures pressure in the intake tract. Air temperature is also measured, throttle position, inlet manifold pressure, and a sensor measuring air temperature, boost pressure, air temperature. Types of supercharging. A TSI engine can only have a turbine. It is controlled by a bypass valve, electric or pneumatic. For example, if there is excess pressure in the exhaust manifold, the flow of exhaust gases will pass by the hot part of the turbine. The peculiarity of such a system is the method of air cooling. In front of the intake manifold, an intercooler of liquid cooling type is installed. The air passes through the honeycomb, inside which the coolant circulates. Activation of cooling is made by a command from the ECU, which turns on the pump, thus starting the circulation of coolant in the air cooling circuit. On a twin-turbocharged car, the engine has an air-cooled intercooler. Problems. Many owners are upset by the fact that their car has a TSI engine. Among the whole line of motors, 1.2, 1.4, 1.8, 2.0, 3.0, some internal combustion engines can cause a lot of trouble for their owners. Among the main problems, oil burn, which can start after 10,000 kilometers, chain stretching. The problems of TSI motors are so significant that they require consideration in a separate article. TSI engine TSI decoding. In conclusion, understanding the peculiarities of TSI motors operation is essential for optimizing performance and efficiency. From their unique design features to the specific maintenance requirements, these motors offer distinct advantages that can enhance driving experiences. By recognizing their operational characteristics, drivers and technicians alike can ensure longevity and reliability. Thank you for watching, and we hope this insight into TSI motors has been informative and helpful for your automotive journey.